for coming out. I'm sure it's been a long conference for a lot of people. I am Jason Rauen. I work with Booz Allen Hamilton in so much as I will not be speaking for them at all. This is a totally independent project that I just kind of did for fun, and actually half on a dare from this guy last year. It's Python 3 and Splunk. Now, the big announcement at this conference in terms of Python and Splunk obviously was that Splunk is building Python 3 into their latest version. This is not about that. This is about an app I built that does a little bit of that and then a whole lot more on top of it. So let's get started. Maybe forward-looking statements, probably not. All right, so extending Splunk with Python. This is a pretty typical use case, right? And so I'm just going to give a real brief history. Python was created in '91 by Guido van Rossum. It's dynamically typed, garbage collected, multi-paradigm, so you do object-oriented, functional, procedural, and most important, it's interpreted at runtime. So what this means for Splunk is Splunk, as we all know and love, contains a Python runtime built into it. It uses Python in a number of ways, especially in its web framework, but also to extend SPL. Currently, Splunk runs Python's latest 2.7 version, depending on what build of Splunk you're running. And then Ada will contain both 2.7 and 3.7 versions of Python. A future version, which they haven't announced yet, I don't think they know, Splunk's going to remove Python 2.7 altogether. For those not in the know, the reason 2.7 is being removed at some point is because it hits end of life on January 1. So the maintainers of CPython will no longer be maintaining it or doing any commits or releases to that version of Python. So in Splunk, the runtime is located in the lib directory under the cleverly titled Python 2.7 folder. And you can run it directly from the command line if you want. You just do in your bin directory Splunk cmd Python, and it will execute Python that Splunk is built with right there in the terminal. This is how Splunk runs all of its Python. It uses that same runtime for everything it does. So what's the problem with that? Why am I even talking about all this? So the first thing you'll notice is with Python and Splunk, you get what you get and that's it. The main value proposition of including Python into Splunk is to extend Splunk and make it do things that the original developers never either intended or thought of, or maybe it's just not worth their time to do it on a company-wide level, right? You have a very specific use case or a special need, and you need to do it, but maybe not every customer in the world needs it. So you can kind of do it yourself. As the current implementation with Splunk means that Python version is fixed to your version of Splunk. And this creates some issues, specifically three major ones. The first issue is you get version conflicts, and you have a version of Python tied to your Splunk version, and as a developer, I may not want to work with that single version necessarily. There may be new features. There's a lot of new features in Python 3, and I want those. I'm a Python developer, and I want to develop in the Python I want. You also have an issue of there's no package isolation. So part of extending Splunk using Python involves adding packages and libraries that the Python community has developed to the scripts you want to run. That's fine and dandy, and you can kind of bundle them into your apps, although it's not easy. The problem is, if I build an app that uses one version of, say, the requests module, and someone else builds an app using a different version of that, and we're both exporting to the global system, we can get package collisions, and suddenly I'm importing the wrong request package, and it's a different version, and doesn't work the way I'm expecting, and now my code breaks. It's not my fault, it's not the other developer's fault, it's not the customer's fault, it just things collide. There's also no dependency management. So If you want to include a particular library and it's very complex, you're going to have to find all of those requirements and bundle them in yourself. So I just talked about all these three issues, so I guess I'll skip these slides. But just kind of reiterating what I'm saying, version conflicts is a big issue, especially now that Splunk is moving to Python 3. In the past, we've only had 2.7 dot whatever. Those micro versions are typically security fixes or bug fixes. Not a lot of features are released into that. But now that we're in the Python 3 world, we're on 3.7 right now. 3.8 just got released. And 3.8 offers a lot of new features over 3.7, and I want to use them, but I'm bound by Splunk's timetable on that. So, as I was saying before, with package isolation, imports can cause conflicts, especially between multiple apps where developers are bundling these things. The solution for that came out years ago in the Python world was the use of virtual environments, but there's no such construct in Splunk. And like I said, with dependency management, you can bundle in. You can bundle in, libraries to use in your scripts that you build in your apps. But if they're complicated libraries, you may spend a lot of time doing dependency chasing where, okay, this module I want to use requires this other module, and that module requires these other two modules, and now you have suddenly 15 things you need to install into your bin directory. All right, so how do we solve this problem? By doing things a little more Pythonic, I created this app called PyDen. It's actually a suite of two apps. There's a manager and the actual deployment app. And basically the idea is a choice of their Python version, provide environment isolation, and give you a simplified package management tool. It is open source. It's posted up on GitHub. It's also currently certified on Splunkbase, but not for cloud. Right now it supports custom searches, scripted modular inputs, and scripted modular alerts. There are some things that I haven't tested yet, such as scripted automation and lookups. Those things should work, but like I said, it's unsupported at this point because I haven't gone through and been able to test them. But there's nothing inherent to the Splunk framework where those things shouldn't work. There are a couple of instances where it will not work at all because of how Splunk runs certain things. The big example is custom REST endpoints will not work with this app. But that's something I'm trying to resolve at some point. Okay, so what's the workflow for PyDen? Basically, there's 3 steps: develop, build, deploy. In the develop stage, the developer will build a list of requirements that they need to run their Python 3 scripts and whatever packages you need, as well as naming a virtual environment. In the build step, the Splunk administrator, where these apps are going to be deployed, will set up a staging server to create the Python runtimes and virtual environments. And then the next step is to take that built package and deploy it out to your deployment. So like I mentioned, the developer of the app that's going to be leveraging PyDen, you just specify your version, any required packages, and a virtual environment name. That virtual environment name is needed to activate the specified environment. And I'll show an example of that here shortly. So how do we actually leverage these environments, right? Anything Python and Splunk is going to kick off with Splunk's runtime. And in version 8, you can choose one of the 2 that they package in, but there's no way to, other than through some wrapper trickery that's all over the answer site, there's no way to sort of choose your own runtime. The way I achieved this was, actually, if anyone's dove into the Python for Scientific Computing add-on, Splunk built that using basically a process swap, and I pulled that same approach. So all the developer who wants to leverage PyDen needs to do is include a couple of import statements at the top of their file, and then it will call a function, and that function will do that same sort of process swap that the Python for Scientific Computing app is running. Okay, so once the developers, built their app and they've got their Python 3 scripts that are using weird packages they want to use, it's then on to the admin of the system who wants to use that, that developer's customer. And this is where the PyDen manager comes in. You set it up on some sort of staging server because it's not secure. Don't run it in production. It is not meant for everyday users. The manager is what will actually download and compile the different Python runtimes that you specify. And then once those are compiled and available to the app, you can build virtual environments off of those versions. Once you have the virtual environment, you can use either a pip-like interface or a dashboard I created to install different packages to it. The way the manager app works is all that downloading and compiling and building, all of that is concurrent with the other PyDen app, and it builds to that separate app. Once everything's done, you take that app and that becomes sort of your deployment object that goes out to either your search heads or indexers that actually need the runtimes in order to execute whatever script you're running. Okay, so it's a lot of words, but let's actually do a demo. All right, so this is not displaying. There we go. All right, so this is the setup screen. I do allow for proxy settings if you need it for internet access. But the big one is you have to put in the path where the actual PyDen app will live. This is the setup screen for the manager, by the way. And so this just gives the manager app the target location for PyDen that you're going to, once you're done building, grab and then deploy out to your machines. There is, if anyone knows anything about Python compilation, you can build it with or without optimizations. This significantly increases the amount of time it takes to compile, so if you're just playing around with it, I'd leave that off. But it will give you I think they say like 10-15% speed increase if you enable all your optimizations. All right, so once that's saved, you can get into the app. All of these dashboards are powered by custom search commands under the hood, so if you just want to jump into the search interface and read the documentation, you can create all the runtimes and virtual environments you want, or just point and click with the dashboards. Like I said, it's compiling Python from source, which takes a few minutes, so I've already pre-compiled a few versions here. And you can see there's, I even have 3.8 compiled. I did that this morning. Okay, so custom commands, right? I built this really rudimentary who am I script, and it says, okay, I'm a Python script, and I'm running on this host with this executable and this version, and here's my current working directory. So you can see we're using the traditional Splunk Python runtime for this. And then we look at the code here. So I mentioned earlier activating a virtual environment. So creating the virtual environment, I have this dashboard, pretty straightforward. You just name it, select the version you want it to run under, hit the little plus button. So Python's going through and using the virtual env module, for anyone who's familiar with it, to create the virtual environment. Please work. There we go. And so now it's available for use on the system. As a developer, I went in earlier and I specified, I need this Py3 virtual environment name. But, just standard Python library, no modules yet. And so this is the code. And so if everything works, I should be able to run this. And yep, there we go. So it's still running on the same computer. I'm not triggering anyone, but the executable that the Python runtime ran as is now located under the PyDen app. I stick all of the runtimes and virtual environments into that app under the local directory. There's a lib directory under that. And we can see, the sys version is 3.7. This is exactly what I wanted. So it's no longer using the Splunk runtime, it's using the one we just built. And
how does it get the environment from the manager to actual client?
What do you mean?
So you mentioned that the manager shouldn't be on the production environment.
Right.
But the actual app should.
Yes.
Right?
So at this point,
repeat the question.
Yeah. So the question was, how do you get the app from the manager server to the production deployment? Because the manager app shouldn't be in production because we're installing and compiling things, and that is not a user function. So best approach, I'd say, is you just dive into the location where that PyDen app is, and then just tarball it up.
And copy paste it.
Right. You'll pull it off with like FTP or whatever your preferred method is, and then you'll just install it to whatever cluster you need.
It's not automated or anything.
It is a manual process right now. You don't necessarily, depending on how you do security around sort of your management servers, what I've been doing sort of in my own personal development environment is I'll actually run PyDen Manager on my deployer. And as long as you have strict controls around who can access the deployer, that's not a bad location for it. And then I set the PyDen target to be in the search head cluster apps directory. Yeah. So now we have a new runtime. Great. We've now achieved what Splunk achieved with 8.0. Hooray. But if you recall, one of the big propositions was we can use pip and the Python package index to add packages and do easy dependency management for these. So I've got this little PyPyHub dashboard, and let's actually look for the Splunk SDK. All right, this is something as Python developers we should all know and, well, maybe love, maybe not. But it's Splunk's recommended way for doing all things Python in Splunk.
It's a love hate relationship.
Yeah. Why is this? I may have to reload. Yeah, there we go. All right. This page is still a little buggy. I apologize. All right. So Splunk SDK. Now, it's one of my favorite things about this SDK is Splunk's recommended best practice on using it in your app is stick it in the bin folder or stick it in the lib folder. And if you have multiple apps where developers all use the SDK, you get to have copies of it everywhere. Or instead, we can use a single virtual environment that we kind of all agree on, saying like, okay, this is the SDK environment, just have this version of Python and this package installed to the virtual environment, and we'll just have the one copy. So we're activating the environment we just installed the SDK to. I've got this try except here for that library. And before, where we were seeing it was returning false, right? The try except failed. We now see it returns true. That package is in fact installed to the virtual environment, and we can use it as we'd like. Okay. So moving back. So what's in the future for PyDen? Obviously, this is still a little on the experimental side and kind of manual at points, and that's all on my map. The first thing it's not, though, is a way to continue to use Python 2.7 after end of life. Don't do that.
It may be painful to convert from 2 to 3, but it is so very worth it. Yeah, so my plan is I'll continue to support 2.7 as long as Splunk is supporting 2.7, but after that it will also be removed and there will be no way supported where you can compile the 2.7 runtime. Actually, since I'm pulling this all directly from python.org, they may pull the rug out on January 1st anyways, so this may not even be within my control. Because I'd have to find an alternate location for those Python source files. And I'm probably not going to do like an alternate mirror of it because there's no way to ensure that's their Python and someone didn't compile something into it. But in terms of upcoming features, I do want to build a requirements file capacity, right? So anyone familiar with Python app development in general, you got that requirements.txt file, so you can easily do just pip install requirements and everything magically appears. That would be nice, I think, for this instead of having to click through every package in that dashboard and make sure it installs correctly. Virtual environment activation, still very manual, right? You noticed I hard-coded the name into the script. I want to try and do away with that and have things either configuration file-based so that the developer doesn't need to necessarily dictate the name of the virtual environment that's going to be activated. And so the developer can focus on just saying, like, here's a requirements file for everything I need to run this script. I'd like to build a modular input that will also automate all of these build processes, right? So it'll identify inputs, stock comp stanzas, where it says, I need this Python version with this virtual environment and these packages. And the modular input will just pick that up and build everything automatically. The admin doesn't have to go through a staging server and all that. And I still want to work on trying to support some of these more tightly integrated pieces to Splunk, like custom REST endpoints, web controllers, Mako templates. But those are a challenge because they're very tightly integrated with Splunk's runtimes. Long-range goal, I'd love to be able to get cloud approval. Some people at Splunk have looked at this in the past, and the cloud people immediately said no. Probably because of the security concerns with the manager app, right? It's, like I said, it's not meant for production use because if a user gets their hands on it, it's just too easy to say pip install malware, and now we have a problem. The app doesn't support Windows deployments yet. Compiling Python was a little trickier on those than I thought it would be. So I would like to get to Windows support. It's going to be delayed until someone asks for it, though. And then tighter integration with other Splunk solutions like the MLTK and the add-on builder. Ultimately, I'd love this to be a replacement for that Python for scientific computing add-on. And so the MLTK could just, like any other developer, here's our list of requirements, go build it. That also comes with another future hope of mine where I can eliminate the two-stage part of this process and get everything down into one, but still in a safe and secure manner where you can't have users just compiling random things. Are there any questions? Okay. All right. Thank you to everyone.